Hey guys, I'm back. It's Miss Wilson. All right, so we're going to look at the fast focus in geometry, and I want you to go ahead and take that packet out. It's standard 5A. You'll find that in the fast focus packet that you hopefully picked up when you got your things in the drive-through line back weeks ago. All right, so find this page. You can pause the video at any time and get caught up. All right, so let's look at question number 1. Okay, these are the types of questions that you would have seen most likely on your STAR test, because we want to make sure you understand all the attributes of your shapes and how to classify them. Just like in science, we classify things by their characteristics, we can also classify shapes in math according to their rules and characteristics. So let's go ahead and look at number 1. It says, which diagram shows a set and subset? That is correct. Okay, so this is kind of like when you have a Venn diagram. When you have a Venn diagram, you have your circles, and what's in each circle separately is what they share or what they have that's unique about them. But where they overlap is what they share with another item or object or whatever it is that you're comparing. Okay, so that's what they would share. So if we look at this one, the larger circle is a triangle, and inside that is a square. So what this is trying to say is that a square is a type of triangle. Now, is that true? No, we all know that is not true whatsoever. So we can cross that off completely. Okay, let's look at B. Okay, so again, this is how this works. The larger circle is it says quadrilateral. So what it's saying is a trapezoid is inside quadrilateral. So is a trapezoid a type of quadrilateral? Well, let's think about this. Okay, let's review. We just finished our unit on quadrilaterals. Quad means 4. Lateral means side. So a quadrilateral is a 4-sided polygon. Now, a trapezoid is also a 4-sided polygon. It is a quadrilateral. So this looks really good to me. Okay, now remember, a trapezoid has exactly one pair of parallel sides, and that's what makes it a trapezoid. Only one pair, exactly one pair of parallel sides. Okay, so let's look at C. We're saying that this outside circle is a rhombus, and this figure is saying that a rectangle is a type of rhombus. Well, that's not necessarily true. The only type of rectangle that is a type of rhombus is a square. So can we say that a rectangle in general, like any rectangle whatsoever, is a type of rhombus? No, we cannot say that. That is not true at all. So this is a lie. And then the last one here, we're saying that the outside circle is a parallelogram. And if the inside circle says triangle, this is trying to say that a triangle is a type of parallelogram. Well, if we think about the definition of a parallelogram, there's your clue for parallel. It would have to have 2 pairs of parallel sides. Well, if you think about a triangle, there's no way you could have any sides that are parallel to each other. So this is not possible whatsoever. Remember, you can always pause the video, try to work it out yourself before I work it with you, or you're welcome to work it out with me as we go. Okay, so number 2. It says this diagram is not correct. So we are going to find out what is wrong, okay? Error analysis. I love doing error analysis because it's basically saying, okay, how can we fix this situation? You really have to know a lot about a topic in order to do error analysis. So let's see if we can figure this out. Now, triangles, we did that last week. I hope you studied a whole lot about those triangles. All right, it says this diagram is not correct. Okay, triangles classified by their angles. Okay, so we have right angles. That means there's one that has a 90-degree angle. Should look like that. And of course, we would close it in with the third side. Then we have an acute triangle. Now, an acute triangle has to have all 3 angles acute. That would look like this. There's lots of ways you could draw acute triangles. All 3 angles are acute. And then an isosceles triangle has, now, wait a minute. is isosceles. Okay, look at this. It says triangles classified by angles. Now this is strange. There is such thing as an isosceles triangle, but it says we're classifying by their angles. Now there is such thing as a right angle. There are such things as acute angles, but what is the other type of angle that we know about? Is it called an isosceles angle? Or is it an obtuse angle? Let's write down the 3 types of angles that there are. We have right, acute, and obtuse. This is not a type of angle whatsoever. It's obtuse. And if you remember from 4th grade and last week too, and we've talked about it a lot this year, an obtuse angle is very open. It's any type of angle that is greater than 90 degrees. And a 90-degree angle is a right angle. So if we took this side and we just opened it up and extended it, we would have any type of obtuse angle. So what we need to do here is look at the answer choice that would change this just like we did it. Okay, so if we change the word angles to sides, well, no, that's not going to help because we'd have to change these 2 words instead of just one. How about change the word right to obtuse? Well, then we'd have obtuse, acute, and we'd still have this isosceles here, and that wouldn't make any sense. So we'd have to change 2 words. If we only had to make one change, which one change would we make? Okay, so here it says change the word acute to equilateral. Well, if we did that, then we'd have to change this to scalene and this to sides, and that's not what we'd have to make a bunch of changes for that. And that's not what we need to do. Hopefully this is the right answer. Change the word isosceles to obtuse, and yay, that's exactly what we need to do because obtuse is a type of angle. So that's the winner. All right, let's look at number 3. I'm going to zoom out just a little bit. This one's pretty wide. All right. Again, it says this diagram is not correct. Why don't you pause the video real quick and see if you can find something that's not correct before we go on. Okay, I hope you found what's going on here. It says, okay, so again, just like I described in number 1, whatever the largest figure is on the outside, it's holding everything inside. So what I mean by that is what this diagram is saying is that everything inside this quadrilateral oval is a quadrilateral or a type of quadrilateral. Now, all of these words are definitely related, but there's something that is wrong. It says the word polygon, so we're looking at this word. It says the word polygon on the diagram should be changed to what? Should it be changed to, now, first of all, why would we change this? I mean, a polygon is a flat 2-sided figure that has all closed sides, straight sides, no curves. And all of these things are polygons, but aren't all of these types of polygons? So really, if this word was going to be here, there would be a larger circle and it would say polygon here because there are other types of polygons. You have triangles, you have octagons, you have hexagons, you have pentagons, you have all types of nonagons. Really cool stuff, but those are all types of polygons. A polygon could be a 100-sided figure or more, okay? But a quadrilateral, or excuse me, a polygon is not a type of quadrilateral. A quadrilateral is a type of polygon. So that's why this word is not in its correct spot. Okay, so what this means is, well, the word we're looking for is a type of quadrilateral. So which word is a type of quadrilateral? Quadrilateral is already there. We don't need to, that's the same thing. How about a trapezoid? What do we know about a trapezoid? Well, we have these separated over here. We have parallelograms, rectangles, squares, rhombus. Those are types of parallelograms. Now, a trapezoid, does it belong in quadrilateral world? Yes, a trapezoid does have 4 sides. Its only rule is that it has exactly 1 pair of parallel sides. So I feel this might be the winner. Now a hexagon, if we put hexagon here, then that means that we're trying to tell everyone that a hexagon, which has 6 sides, is a type of quadrilateral. And that's not true. That's just weird. And then we're also trying to say then, if we put octagon here, that an octagon is a 4-sided figure. And that's not true. We all know that an octagon has 8 sides. So these are not correct. We would have to put trapezoid right there. Okay, I bet you figured that out. All right, we only have 2 more questions. This is a short one. All right, I'm going to zoom in just a little bit. Okay, so it says look at the diagram, and here is a Venn diagram right here. Okay, so in other words, what do both of these, what shape down here has both of these characteristics? Okay. All right, so let's look at the diagram. It says, which is an example of a triangle that is both scalene and right? Now, if you think back to your notes, go back in your notes if you want to find out before we go over it. What is a scalene triangle? Okay, well, I'll tell you. A scalene triangle is a type of triangle that has no equal side lengths. All the side lengths are different. And remember, we had a long conversation about these tick marks that are in our geometric figures when we're talking about measurement. Okay, if they're all the same, one tick mark means this is equal, this side is equal, and this side length is equal. And then, like here, we have 1 tick mark here, 2 here, and 3 here. This would be a scalene triangle. Okay, let's go ahead and write scalene. Always label everything. This is scalene, but it said that it has to be both scalene and right. Do you see any right angles there? No. No right angles. No right angles. This would be scalene and acute because all 3 of these angles are acute. Now let's look back at this one. We know this is not scalene because all 3 sides are equal, and that's called an equilateral triangle. All right, so that's not going to be the answer. This is scalene, but no right angles. Okay, let's look at this, and we can tell just by marking, or the markings that they gave us, this side has 1 measurement, this side has another measurement, and this side has a different measurement. All 3 measurements are different. Therefore, it is a scalene triangle. And then if you look right here, this indicates that it is a right angle. So it is in fact scalene and right. But let's go ahead and review and evaluate what kind of triangle this is. This is a right triangle. We can tell by the square corner there. So we know that it's right by its angle, but these 2 sides are equal. You can tell by looking at it that this side is not equal. I could, if I wanted to, go ahead and put a different measurement mark, indicating that has a different measurement than the other 2. You can clearly see that this side is longer than both of these. So if at least 2 sides are equal in a triangle, it is called isosceles. Okay, so that's right isosceles. So this would be the winner right there. Fluffy cloud. Okay, friends, last question. Aren't you excited? Let me move my cup. Okay, now here is a graphic organizer. This is called a tree map, all right? Okay, so at the very top is the overarching category. So we have quadrilaterals. Everything under this tree is a type of quadrilateral, if it's true. So it says, okay, let's look. We have it going in 2 parts. This part of the tree are all parallelograms. This part of the tree are only trapezoids, okay, because trapezoids are not parallelograms. So we know that they do not belong in the same part of, or in the same category, in the same part of that tree. Okay, so let's look and see what we would put in this part. We have to branch off. There are types of parallelograms. We have rectangles, and the very special rectangles are called squares. All right, so if it's a parallelogram, it has to be certain things. So what does the word, it says, what should be written in the empty box to best complete the organizer? Okay, now remember, pause the video and see if you can figure it out before we go over the answer. All right, pause that video. Bet you'll get it. Okay, So let's see, equilateral. Well, when we think of equilateral, it does mean equal sides. Honestly, a square does have equal sides. But when we think of the word equilateral, we think of triangle. So is that going to belong here? I don't think so. Okay, now again, just like we did in number 3, polygon is not a type of quadrilateral. A quadrilateral is a type of polygon. So if we had the word polygon, it would be way up over quadrilateral because a quadrilateral is a type of polygon. So I'm not going to put that there because it does not go underneath. It's like an umbrella. Okay, what goes under the umbrella? Okay, polygon is like the sky. Okay, all right, rhombus. Now, what is a rhombus? If you think about your notes, which I hope you took really good notes, okay? A rhombus is a type of parallelogram, which that means it's a type of quadrilateral that has 4 equal sides. Now, it doesn't have to have right angles, but it does have to have 4 equal sides. So let's write that note. I want you to write 4 equal sides. The angles do not have to be right angles like a square, which also has 4 equal sides, but it does have to have 4 equal sides. So we could say that a square is a type of rhombus, but all rhombi are not types of squares. So just like we've said before, all rectangles are not squares, but all squares are rectangles. So you could say that too. Okay, all squares are rectangles, but not all rectangles are squares. So all squares are rhombi, but not all rhombuses or rhombi are squares. Okay, so I think that goes there because look at this next word. A triangle is not a type of quadrilateral on any planet except on planet Zoltan. So there you go. We are not there. We are on Earth. So we're going to put a rhombus right there. All right, friends, I hope you enjoyed it, and geometry rocks.